Section 8-1, Part 2, Identifying Linear and Nonlinear Function Rules. Is each function rule linear or nonlinear? So let's look at A part, y equals to x squared. Based on what we've talked about, if you have an x and a y, they both have to be raised to the first power in order for it to be linear. Well, y is raised to the first, but x is raised to the second. Therefore, this one is non-linear. Now, I'm going to graph this, and I want us to see what this graph looks like. I'm going to use a table, and I'm going to pick my values of x, okay? I'm also going to pick a negative number this time, all right? Now, if you have a variable raised to a power, this is the same thing as if we have parentheses around x. So I'm going to write it y equals x squared. So let's plug in 0. I have y equals 2, 0 squared. Well, 0 squared is 0 times 0, which gives you 0. Therefore, when x is 0, y is 0. Let's plug in 1. Y equals to 1 squared. Well, 1 squared means positive 1 times 1. When you square a number, you're multiplying it times itself. So 1 times 1 gives you 1. Therefore, when x is 1, y is 1. Let's plug in 2. Y equals 2. Put parentheses around that 2 squared. That means you're squaring both the number and the sign. This means 2 times 2 gives you 4. So there I have the point 2, 4. Now let's plug in negative 1. If I plug in negative 1 in for x, I'm plugging it in to the original problem with parentheses around it. Anytime you have a variable raised to a power, it's parentheses. So negative 1 squared is negative 1 times negative 1. You're squaring both the number and the sign. Negative 1 times negative 1 gives you positive 1. So therefore, when x was negative 1, y was positive 1. I'm going to also go ahead and plug in negative 2. So y equals to negative 2 squared. Negative 2 squared, squaring both the number and the sign, would be negative 2 times negative 2. Negative 2 times negative 2 gives you positive 4. So negative 2, 4. So if I was to plot all of these points, you will see that it is not a line. 0, 0, 1, 1, 2, up 4. Okay? Then I have negative 1, up 1, negative 2, up 4. So negative 2, up 1, 2, 3, 4, something like this. So this is what we call a parabola. It is a U. It looks like a U. So anytime you have one of the variables raised to the first power and the other variable raised to the second power, this is going to be a parabola. It is a U, okay? So you can definitely see that this is a non-linear graph, all right? So here is a better graph here. This function y equals x squared is not linear. We made tables of values, and that helped us graph. So you see, I chose, first of all, 0, 1, and 2, but then I also chose the negative 1, negative 2, so that you could see what it was doing on the left side of the graph. So anytime you have an x squared, one of them squared and one of them's to the first power, it's going to be a u, all right? Okay, next, let's look at B. B part is y equals to 4x. Y equals to 4x. Is this linear or non-linear? Well, both x and y are to the first power. It's in the form of y equals mx plus b. So yes, this is linear. Okay, this is linear. Now, so the graph of this graph of y equals to 4x looks something like this. There's the graph, y equals to 4x. It passes through the origin, Your slope is 4 over 1. You could rise 4, run 1. Here, some values were picked. You plug them in one at a time, and you have graphed this line. So y equals to 4x. Okay, so you could just make a table, plug them into the equation, y equals to 4x. This chart picked -1, 0, and 1. We could still pick 0, 1, and 2. Plug them in one at a time. 4 times 0. 4 times 0 would give me 0. 4 times 1 would give you 4. And 4 times 2 would give you 8. So there's more points on the same graph. So yes, B is linear. All right, well, let's go back and continue looking at the remainder of these. Looking at C. Here I have C is y equals to -3. Y is to the first power, x is to the first power. So therefore, yes, this is a line. So C would also be linear. Its graph would be a line, and here's its graph, okay? So there we have C equals to y equals -3x is linear. A table was used, but again, you can also go by my rules. If y is to the first and x is to the first, and it's in the form of y equals mx plus b, then yes, it's linear. You could use a table, plug them in one at a time to see that C is linear. Next, let's look at D. Let's talk about D. D is y equals to 8x. D is y equals to 8 divided by x, 8 divided by x. Remember, I said if x is in the denominator, this is non-linear. Your x cannot be in the denominator. So D is y equals to 8 divided by x. So this is non-linear. So let me show you what the graph looks like of D. Here's the graph of D. We would have to plug in several points to see that this is what this graph looks like, okay? So D is non-linear. I could look at the equation, and now you should be able to look at the equation. If you have a variable in the denominator, it is non-linear. So you can see this is not a line. So D is not linear. And then the last one we have is E. Let's look at E. E is y equals to x minus 2. Is this linear or is it non-linear? Well, you can see that it is in the form of y equals mx plus b. Both x and y are to the first power. You can see that. You can see that it's in the form. It's got a slope of 1. You see it's got a y-intercept of -2. We could use a table. We could pick 0, 1, and 2. We could plug those numbers in. So y equals 2, plugging into x minus 2. If I plug in x is 0, 0 minus 2 would be -2, forming an ordered pair. I could plug in 1 in for x, 1 minus 2. 1 minus 2 is -1, so there's another ordered pair. And plugging in 2 in for x. Y equals to 2 minus 2, which would be 0, okay? So if I plot those 3 points, 0, -2 is here. 1, -1 is there. And 2, 0 is there. So there is my line. You see, this is your y-intercept. This is where the graph touches the y-axis at 0, -2. Every time you let x be 0, that is your y-intercept. It's the same y-intercept that you know from being in the form of y equals mx plus b. B is negative 2. You go down on the y to negative 2. But for every y-intercept, x is 0. Now, I'm going to also talk about this is the x-intercept. The x-intercept is where the graph crosses the x-axis. And the name of this point is 2, 0. So for every x-intercept, y is 0. For every y-intercept, x is 0. So this was your y-intercept. This was your x-intercept, okay? So, yes, this is a line. So ends up E is linear. Yes, E is linear, okay? And you see here I have the same graph of y equals x minus 2. They just picked different numbers here. Where I picked 0, 1, and 2, they picked negative 1, 0, and 1. But as you can see, it is the same line. It is the same line. So no matter which points you pick for x, once you plug them in, you're just finding more points on the graph. So looking back at these different choices we had, A was nonlinear because one of them was squared. B was linear. C was linear because it's in the form of y equals mx plus b. Both x and y are to the first power. D was nonlinear. You cannot have the variable in the denominator. And E was linear. It's in the form of y equals mx plus b. Remember, you can have one with just an x, or you can have one with just a y. If I had had these equations, these two would have been linear. Because just an x, just a y, raised to the first power, they are lines. Having y equals to a number, this is your horizontal line. Having just an x equal to a number, this is a vertical line.